Sam, just a real quick question while we're waiting for Mr. Pham. Hey, that one button you said to put the notes on is insert, and what was the other thing?
Insert, and then you want to do is click on add text.
Okay, got it.
Okay,
Thank you.
you're welcome.
Okay, so now we start with that. It's now DC direct current flowing only one direction. Okay. Like your car battery, that's DC. Okay. And the other one they call AC. Okay. Alternating current. That will be displayed for you the sideways. You can see that they will be vary with the time here. Okay, vary with the time. The amplitude they can going up, positive, and they will be a negative and keep going. Where you can get that AC signal.
Generator. From your wall.
Exactly. Outlet on the wall in your house. What voltage?
120.
120. Okay. Now we can go a little more detail on this thing. That is the name of the signal we call a sine wave. If you're looking at the outlet of your house by oscilloscope, you can see they exactly the same. Okay. And the amplitude here vary with the time. So that's why we call a time domain. You get two domain. Okay, one will be a time domain and another will be a frequency domain. Right now, we're on the time domain. Okay, and basically this way try to get some definition. First thing, the voltage from 0 to the top or 0 to the bottom here, they call a VP. Okay, and the voltage from the top to the bottom, that what voltage will be peak to peak. So by the display here, V peak equals 5 volts, either up or down, that's the absolute value. And the peak to peak will be a double of the V peak. They will be 10 volts. Okay. When you try to see outlet voltage using the meter, you cannot get this signal. You will get the voltage they call a VRMS, effective voltage. Okay, you can see right here, VRMS. And the formula to calculate the VRMS, okay, from the V peak, you take 0.707 times V peak. That's what you get, what we call VRMS. So when you see the sine wave, you're able to get the V peak or peak to peak, but not VRMS. If you want it, you have to do the calculation, 0.707 times V peak. That's why when you're looking into your outlet with a meter, you can get 120 volts. However, if you're looking by the oscilloscope, you can see the sine wave with 370 volt peak to peak. Okay. And also we get another definition for the period. Period, that means in this one they call T. T will be going from complete cycle. From here they going up, they going down, going up again. So that will be one period. Okay, and also you get the frequency and the relation between period frequency is you can get T equal 1 over F or F 1 over T. So if you measure the T, you get the T, you're able to calculate the F. Okay, in this formula, T must be in second, F must be in hertz. And this is the following. I given you the definition for each one. Cycle, one complete occurrence of repeating wave periodic signal, such as one positive and one negative alternation of the sine wave. Okay, so the part up here they call a positive alternation, and the part down here will be negative alternation. Okay, and the definition frequency, the number of cycles of a signal that occur in 1 second. And the period, the time distance between two similar points on a periodic wave. That is to cover everything regarding into the sine wave. Okay, if you're looking into the sine wave, you're able to recognize everything here. Okay, for here you can see that vary with the time. At this one will be a 1.0 millisecond, and this point right here 0.5 millisecond. Okay, so any question? Not we go.
Look like Mr. Abdullah. Mr. Abdullah look like he has a question. Did you still have a question, Mr. Abdullah?
No, that's good. No. Thank you so
Okay.
much.
Look, yeah, look like you have your hands. Look like you have your hand symbols up and so.
Yeah.
Okay.
Okay, if you get you want to take or anything, take to Sam. Okay, I'm taking, I'm not looking at anything else. Okay, now we're talking about power of 10. Okay, today you go to get 10 power of 2 equal what?
100.
That means 10 times 10,
100.
100.
100.
100.
Okay, now power of 10, you can see the first one here, the handle with the last number in electronic system, is power of 10 notation. The number 10 equal a base, and its power equal a exponent. Okay. And now you can get, see, they give you example, 247,000 equal
7.
okay. So they wanted to the power of 10. So in this case, you can move to the left. 1, 2, 3, 4, 5. 2.47. And time to the power of 10. You have to know what the power. Okay, 1, 2, 3, 4, 5. So that's why they will be power of 5. Okay. And now you can see the number 0.00 here. They want power of 10. So you can see how many numbers. 1, 2, 3, 4, 5. Okay. And basically to move to the left, you get 3.69 right here. Okay. So basically you will be move 1, 2, 3. That's a 10 minus 3. Okay. And the table here given to you equivalent. Okay. 100,000 power of 5. 10,000 power of 4. 1,000 power of 3. Okay. And also on the other side, you can get like 0, 0, 0, 1 will be -3. The thing is you get 1, 2, 3 number. Okay. 10 power of 0 equal
1.
1. Any number with power of 0 equal 1. Okay. Now they're talking about multiplication, division, power of 10. Okay, to multiply number in power of 10 notation, multiply their base number, can add their exponent. So they given you example, 1.2 times 10 power of 3 times 1.5 times 10 power of 4. Okay. So basically, easy way to do. Take 1.2 times 1.5. Okay. And the power will be add them up. So that's why you can see here, 1.2 times 1.5. And the power will be power of 3 adding power of 4. So you get 1.8 times 10 power of 7. That's just a very, very basic thing. We need to get through it. And now for division. They say subtract exponents in the denominator from those in the numerator. They take 4.5 times 10 power of 2 divide to 3 times 10 power minus 2. So basically, you just take 4.5 divide 3, okay? And the power, when you bring it up, you will be take a 10 power of 2 minus 2 minus 2. The answer will be 1.5 times 10 power 4. Okay, now you can do for me next one. Example. Convert the following number to power of 10 notation. Then perform the operation indicated. How can we do? You guys can do it. I can give you the answer right here. 28. Can you get 28?
I don't get it.
You get it?
No, I think
No.
28 is wrong. It's not correct.
Okay, I try. 276.
Yeah.
That means 2.76.
Times 10 power 2.
Yeah. And you time 0.009
9 times negative
9
3 times
time
10 power negative 3.
minus
3.
3.
The mean.
Okay, so you take 9 times 2.76, right?
Yep.
And basically you can get 2.76 times 9, okay,
Divide 10.
times 10 power
Negative.
of
Negative.
minus
Negative
1,
1.
right?
Yep.
Okay, so see what you get.
Yeah, I don't get it. I don't get 28. I got 2.4884.
Okay, let's see. I try to see 2.7
It should be 2.5. Yeah.
times 9. Okay, divide
10.
10.
It should be 2.5.
2.48, right?
No.
2.48.
Yep. The 2.5. You
So
round
that's
up as
wrong.
2.5.
The book is wrong.
Okay.
Okay, so I given you the answer, right answer.
The 2.5.
It's 2.484.
Okay. 2.484.
Correct.
Mhm.
Wow.
You can route 2.5, yeah.
Yeah, that's okay. No big deal.
Okay.
Next one, what you get?
Yeah, that's correct.
Is it 4.91?
That's correct. Yeah.
Oh, that's correct.
Yeah.
Okay. So the first one is wrong, but the second will be correct. (4.91) times 10 power of 3.
Oh.
Okay. Only thing what you need for now, just write down the correct answer and try to work again. Now they're talking about addition and subtraction. To add or subtract, first add just all numbers to the same power of 10. It does not matter what exponent you choose, as long as they are the same. Okay, now they say adding 3.25 times 10 power of 2 to 5 times 10 power of 3. Okay, so either way you want to change, first thing you must change the same power. You want to using power of 2. Then you must be change 5 times 10 power of 3 to power of 2. Okay,
Yeah.
so now you can see on this one here, first thing you say 3.25 power of 2. Okay,
Mhm.
and you adding.
Yeah, you need a common factor. Yeah.
Okay, you have to bring 10 power of 3 to 10 power of 2. Make sure they get the same power. So they will be 50, right?
Yeah.
10 power of 2. Then you just add the number. Okay. In here, I already given you the solution.
Yeah.
Okay. So the answer will be 53.25 times 10 power of 2. Okay. If you want to using 10 power of 3, that means on this guy here, you have to bring it up to 10 power of 3.
I mean, yeah,
0.325.
0.325. Yep.
Yeah, that's easy. So the thing I already get here. Now, power. Raising a number to a power is a form of multiplication, division if the exponent is negative. For example, if you get 2 times 10 power of 3, okay, then the first thing you just get the power of 2 to the power of 2. Okay, 2 power of 2 means 4. Okay, 2, 10 power of 3. Okay, power of 2. That means you take 2 times 3, you get power of 6. Okay, and also integer fractional power represent root. Like you take square root of 4, you get 2. Okay, most of the people already know how to take square root. Okay, so this is just an example for the guy looking into that, but we don't need that much. Okay, the next we'll be talking about engineering prefix. So when you get a 10 power of 12, they call it tera capacity, power of 9 giga. capital Z. Look like you go to buy the computer. They asking you how much memory you want. You say a gigabyte. Giga mean 10 power of 9. Okay? And you learn digital, you know, byte will be 8 bit. Then you take 8 bit times 10 power of 9. Then you know your memory. Okay? Mega 10 power of 6, kilo 3, milli minus 3, micro minus 6, nano minus 9, and pico minus 12. Okay? And now they say convert 0.1 megavolt to kilovolt. Mega will be 10 power
Six.
of 6. Okay? That means you get 0.1
Mhm.
times 10
10 power 6.
power of 6. And the kilo will be 10 power of 3.
3 of 3.
Okay? So that will be mega, right?
Mhm.
And if you want kilo,
So
Yeah, you
100
can-
times 100 kilowatt. 100 kilowatt.
look like 100, right?
Yeah, 100 times 10 kilowatt.
100 times 10 power of 3, right?
Mhm.
But with 3 will be for the kilo.
Kilowatt.
So that's why
100 kilowatt.
100 kilo.
Kilowatt.
Okay. Then they say express the following engineering notation. Number A. This is the key point. Try to understand this thing. They want to express 10 times 10 power of 4 volt to engineering notation. Who know how to do? If you're looking into the engineering notation, you can see they get power 12, 9, 6, 3, minus 3, minus 6, minus 9, minus 12.
Yeah.
But they don't have a power 4.
0.1 times 10, yeah, mega times 10 power of 6.
Yeah, you can do
Zero.
easy way. Okay, I
Oh,
can say 100
100 kilowatt. Yeah.
times 10 power of
3.
they want the power must be matching to engineering prefix. That's easy. Okay, like 0.1 times 10 power of 3 watt. Then you can change it to the milliwatt. One watt equal
0.001.
1,000 milliwatt, right?
Mhm.
So
Yeah.
that one is they can be equal 0.1 milli, right?
Yeah. Nobody,
How
No,
about
that's,
250 times 10 power 7 second? If you're looking onto the prefix engineering, we don't have a power 7.
I see.
You can get only power 6 or 9 or 12 or minus 3, minus 6. So they give me equal 2500, right?
So since the B is 0.1 kilowatt, not milliwatt.
It should be kilowatt.
Yeah, kilowatt. A B.
B.
Yeah, it's a
Now, that will be
kilowatt. Yeah, not milliwatt.
Kilowatt.
is it kilowatt?
Yes.
Okay, so 0.1 kilowatt, you're right.
Yeah.
And same thing, the A we can do 100 kilo kV.
You say 100
kilowatt. Yeah.
AB. A.
you
It should
talking
change.
about which one, A or B or C?
A. You
A.
should change the kilowatt.
Okay.
Yeah.
That's okay. You can change
It's okay.
to what? Okay. But what I try to bring it up here, they want to be engineering prefix. That means the power must be 12 or 9 or 6 or 3. Okay. That's the
Right.
only thing they want. Or -3, -6, -9. Okay, now you can see that like your car battery. Okay, this is the battery. This is a positive. Okay, and this will be a negative. This is DC. That means you can get a current flowing from positive. Okay, go to the light and going back to the negative. Only one direction. From positive to the negative. So reason you get the current flow. The thing is you get the electron moving. Okay? Electron will be moving from the negative to the positive. Okay? So sometimes you reading the textbook, they draw the current this way. Okay? I. That means they draw electron current. They're telling you the current electron moving from negative to the positive. However, we're using conventional current. That means the current will all the time must be positive to negative. Even that only one current, that I. Okay? So if you reading the textbook, you see they draw going from negative to positive. Basically, they're using electron moving. Okay? Without electron moving, you cannot get any current. However, again, we're using conventional. Current must be flowing from positive to the negative. Okay? When you turn on your light, okay, and you can see the light will be on. Okay? That means inside the light right here, there's a resistance. Okay? So if you touch into the light, what you feel? They will be hot, right?
Mhm.
That means electrical will be converting into the heat.
Energy, heat.
Okay, they
Energy.
convert into the heat. Okay, so that's why you touch it, you feel hot. Okay. Now, next we're talking about resistance. Basically, the resistance just try using to control the current. They say resistance is opposition to the current. Okay. Component manufacturer to have a resistance equal a resistor. Conductor like copper or little have a little resistance. Copper or like the wire. Okay, they get less. And resistance, okay, symbol will be this is a symbol. You see that one, you know that resistance. And this is the real one. Okay. A letter symbol ER. Unit of the resistance will be ohm. And they can using that for ohm. Okay. Only thing, make sure you understand a resistance will be opposite to the current flow. You get less resistance, you get more current. Okay. And if you get a bigger resistance, you get less current. Now, if I get a resistance here, burn out. What resistance?
Yeah.
If the resistance is burn out, what resistance you're supposed to get.
Would that be 0?
0 means short.
Sure.
No. 0 means no resistance, less resistance.
Infinity.
They have to be infinity.
It look like the
Repeat your question, please.
Go ahead.
Infinity.
I say when resistance is burned out, if you measure resistor, you can get infinity O. That means very, very big resistance.
Mhm.
For example, you see this is the light on your car. Okay? Now, when you turn on, the light, they not on. That only telling you the resistance here, they be broken. That means the current cannot flow it.
Mhm.
Okay?
Mhm.
That is telling you if the resistor be burned out, then resistance have to be infinity.
Infinity.
Okay? When the resistor is shorted, that means they draw maximum current. Now, that I given to you a little more detail inside one resistor. You can see that resistor, they can get the coding here, color code. Okay? And in order to get the value of the resistor, you get 2 ways. First way, like assembler people, they looking into the color code, they can telling you what the value. And another way, you can using the meter. You can measure the value. Okay? To the technician, if you know the color code, that's better, but you don't have to. Okay? The thing is, every time you want to know the value, you must be using the meter. And this will give you a little more picture on the resistor here. Okay, that means the bigger side, they will be handle more power, more watt. Okay, they can give you 2 watt or 1 watt or 1/2 watt, quarter watt. Okay, that means small side, they handle less current. If you connect more current, they will be burned out. Okay, and now also they given you another more picture for your guide. Power resistor. That's still resistor, but they power resistor, they can handle more power. Also, you can get that will be integrated resistor network. That means inside here they can get 1, 2, 3, 4, 5, 6, 7 resistor. Okay, they call a integrated resistor. Why they want this kind of resistor? The thing is, you understand, when they build the circuit board, they want less room. So that's why instead to have to connect 7 resistor, they can using 1 IC resistor. Okay. And now they given you another one for variable resistor. So basically, this resistor here, you can vary the value by turn the rod here. You can get different value. That's what they call a variable resistor.
So with this one, you could vary the resistance, and with the other one, what's the difference between the two?
The other one, fixed resistor.
It's what?
Fixed resistor, you say 1 kilo ohm, they everything 1 kilo ohm, cannot change.
It's fixed. It can't be changed.
Yeah, you cannot fix it. But this one is variable. You can change to 2K, 5K, 6K, depend on the size of the variable. So you can see the difference. And normally you see this resistor here, fixed value. Okay? That means 2K, then they be 2K. You cannot make a difference. Okay? If you want different value, then you have to using the variable resistor. Okay, now this is will be a color coding. So the first one you can get 4 bands, and another one will be 5 bands. 1, 2, 3, 4, 5. 5 bands. Next one here, 1, 2, 3, 4 bands. Okay. I telling you what the difference between 4 bands and 5. 5 bands will be more accuracy. Okay. Cost more. 4 band will be cheaper. And now they will be assigned. First band will be first digit. Second band a second digit. A next will be multiply. And the next one will be a tolerant. Okay. 5 band, then you can see the tolerance or reliability. That means more accuracy.
Mr.
And-
Pham,
Yeah,
I got a question.
yeah.
From previously, when we learned about the precision resistor, the 5-band one,
Mhm.
the first 3 band are the digit, the 4th one is the multiplier, and the 5th one is the tolerance. How come in this slide here is used, band 4 is tolerance, and band 5 is reliability?
Okay, we'll see in here. Let's see.
How do you tell the difference between the two then?
Okay. Band 4, that will be a tolerant. Okay. Band 5, basically just a tolerant.
Right.
Band
But
4, that means tolerant for 4 band. Band 5 means the tolerant for 5 bands. Okay. And now in here, band 3 will be multiplied. Okay.
Shouldn't that be the digit in band 4 is the multiplier?
I don't think so.
But isn't that what we learned previously?
Okay, let's see what we do in calculation here.
Okay.
Okay, then see, I can tell you. Now, they given you this resistor here. Okay, they say determine resistance of carbon film resistor having color code. So first will be a brown, gray, orange. Okay. And then will be tolerant. So in order to do it, first thing you're looking for brown. Brown here will be 1. You see here. Right? So brown will be 1. The next gray, second one, gray will be number 8, right?
Mhm.
So they will be number 8.
Mhm.
Okay. Third one, orange. Orange number 3. Multiply. That means multiply by what? 10 power of 3. Okay. And then they get the red 0.1. 0.1 here. Right? That means plus or minus 0.1%. So basically, that will be 18 times 10 power of 3, okay, ohm, plus minus, they say here is 5%. I want to know what 5%, okay? Gold is 5%, okay? So gold is 5%, and the red will be 0.1%. Right here, you can see that with reliability of 0.1%.
This is different from handouts from previous semesters. I'm looking at a older handout where it does say that the third band is the third digit, like the previous student had said.
Okay, I will check that.
Right, and if you Google how to read a resistor, they always give you the fourth one as the fourth one is the multiplier, the fifth one is your tolerance. There's nothing about reliability.
That is the fourth one I saw.
Right.
I will be quicker.
No, this one's actually confusing everybody from who learned the first.
Okay, just give me quickly. I take my hand out from last fall. Then I can tell you.
Thank you.
Yeah, so pretty much in general wise, yeah, the fourth, the fourth band would be the multiply. That's like in most general resistor, that would be the case, and the fifth one would be the tolerance. But there always there's a certain special case resistor that the fourth band is the tolerance. And the fifth band would be the reliability. There's a special case of resistor.
So how do you tell which one to use when you have the less than 2 resistor?
They will define that. Most companies do have those resistor at their place. So pretty much, if they have the special case resistor, it would tell on the blueprint.
So
that is a second type of resistor that also has 5 bands.
Yeah, there's only only a few there's a few special cases that use those.
Okay.
So, but in general, the general you want to go with the other one, the one with the handout from the one before.
Okay, now basically this is draw. That will be multiplied right here. Okay, and that one will be tolerant.
So we don't have reliability.
I will retake it. Okay, so if we're doing calculation here, I recalculate it. Okay, we know the first one, number 1, right? The next one, number 8. Orange. What number?
3.
Number 3. Orange, number 3. Time. Go. Oh, man.
5%.
Okay. This guy is screw up. The thing is, I go on here.
For my one, it should
0.1.
go. This should be enough.
Okay, I will be correct this thing. This is look like inside the book, the new one.
Is there a textbook for this class?
Now, I get the two different book. Okay, so don't calculate on this guy. Let's see if we get another one.
That is a kind of resistor. It's just not the kind of resistor that we meant to discuss.
Yeah, you want to talk about the general type.
Got it. Okay.
So this color coding is much less common. Is that correct?
Correct.
Is there a specific application where you would find it?
Like I said, you probably have to work like in like most of the time you use the reliability is mainly for doing research.
Okay.
Because they need those special ability to do that. But in general application out there that you use, like out there like in the military, no, you just use the general 5-band resistor.
So that is normally you can get the 4-band. Okay. They're adding another band for reliability. So if they doing calculation here, they say 18 plus times 10 power 3 plus or minus 5%. So basically they correct for 4-band. Okay. And they adding one last band for reliability.
So I have a quick question.
Yeah.
So I just looked this up online, and so some resistors have 6 bands for a, let me get the word right, a temperature coefficient. I take it we won't have to learn that here in this class?
No, like I said, most of those are like very, very specific one. Most of those you won't run into it.
Okay.
Yes.
Okay, now I go by this one. Okay, just a 4-band. So you get, I just talking about 0.5K, 18K. $18K plus minus 5%. Okay, so now 5% of it 18. 18 times 5 divide 100. 180 divide 100. Get 1.8, right? Is it 1.8?
No, 0.9.
Okay, 0.9. Okay, so that means you calculate for 5%. So now we have to come up with the upper limit. Upper mean 18 plus 0.9. So they get 18.9K. And we need to calculate the lower limit. 18 minus 0.9. What you get?
17.1.
17.1.
Okay.
1K, right?
Right.
Okay, the question is, if I get resistor here, I measure R equal 17K. Is it okay or not okay?
Should be okay.
No, it's not okay.
Shouldn't you put 17.1? The exact.
Okay.
Not okay.
This is
Okay. That will be okay, right?
Okay. Yeah.
Yeah, the thing they going from 17.1 up to 18.9. So that resistor still be good.
Mhm.
Okay. So if I get resistor equal 20K, I measure 20K. Is it okay?
No.
No.
They say out of tolerance. Now you understand what that means for tolerance. So inside the upper and the lower limit, they still good. However, if you measure 20K outside of that limit, then they not good. Or you measure 15K, they not be good. Anyway,
17K is outside too, so it's no good, right?
okay. Now, make sure 0 right here, right? You can get 18 here. You can get 17.1 here. So 17 right here, right?
Right. So it's not okay.
Not okay.
Right. Thank you.
Resistor manufacturer produce carbon composite resistor of 100 mega ohm with a tolerance of plus minus 5%. What will be the color code on the resistor left to right?
Gold.
A or B or C or D? Multiple choice.
Mm. I will say B.
Oh, this one here. They given you the answer right here. The fourth one will be brown. The next one will be a black. And the violet. Can you get the number? Can you get that answer?
Nope.
No, go into the table. Okay, now the fourth one, they say 100 what? 100 mega ohm.
107.
100 mega ohm. Okay, so I given you the answer will be what? Brown. Brown will be what?
Brown 1.
Then the next will be
S1 is black.
light.
Black 0.
Light will be 0, being 1. Right?
Violet. Violet 7.
Let's see. You said the light will be being 0. They will be 0, right? That's the black. And number 3,
Violet.
violet.
Violet 7.
Violet 7. That means time 10 power 7. Okay. And the last one, they telling you gold 5%, I think. Gold will be 5. Blood 5%. So they will be 100 times 10 power of 6. Okay. Blood minus 5%. Okay. So that will be in mega O, right? So basically what I telling you, they given the value and they asking you going to byte to tell what the color code. Okay. However, that we don't need that for technician. Okay. You go to the college, maybe they asking you. Let's say, example, given register having the following color code, determine the resistance, tolerance, reliability, each component, express uncertainty in both percentage and all. Same question like the first, and now they given you a brown, green, yellow, silver. Then you telling what the value. Okay, we already did it. I just doing the first one only. Brown, what number?
1.
1. Green,
5.
5. You say 5, right? Multiply by yellow.
10,000.
You get 10,000. Let's say yellow. Yellow will be 10,000. Okay, silver, how many percent?
10%. 10%.
Silver will be 10%. Blood, okay? So that's what they want. So you can do for the rest. That means they gave you looking into the color, you're able to know the value. Normally for the technician in the real job, they not asking you that thing. That's for assembly. Okay? If you know, that be fine. Now we know a little more conductance. Conductance Z is defined as the measure of the material ability to allow the flow of charge and is assigned to every unit in assignment. Unlike conductance indicates that material is able to conduct current well. Okay, well, I don't care what they said, but I tell you right here. Conductance will be reverse of the resistance. G equals 1 over R. And the unit of the conductance will be assignment. Okay, and the resistor will be in Ohm. Now they say determine conductance of the following resistor. That resistor is 5 ohm, 100 k ohm. And now easy to find G equal 1 over R. So basically 1 over 5. Okay, then 0.2, right? Assignment. And if you want to do for a B 1/100, that's what you get, conductor. We're not using much on the conductor, but I adding in the lecture this time. Make sure you understand conductance will be reverse of the resistor. And now we go to the Ohm law. Okay, now you get the voltage here, you get a resistance, and you get a current flow. The relation between the voltage and the resistor and the current. That's what we're using Ohm law. E means that will be E voltage equal I times R. In this formula, I have to be in current, ampere. R must be resistance, and E must be voltage. And from this formula, okay, you can calculate I. I equal E divide R, or R equal E divide I. Three formula, okay? We must know we're using all the time. For example, they said the lamp in this figure draw 25 milliamp when connected to a 6-volt battery. What is its resistance? Then you apply the Ohm law right here. R equal E divide I. Okay. V is 6 volts. I will be 5 milliamp. You must be using the amp. So that milliamp must be changed to the amp. 25 times 10 to the minus 3 amp. Okay? The thing is the formula I equal E divided to I. R must be in ohm. E must be in voltage. I must be in the ampere. Okay? So you need to change to ampere by divide times 10 power minus 3. Okay, so take it here, you can get this answer here. Resistor 240. So this what we call a Ohm law. Okay, remember, E will be I times R, or I can be equal E divide R, or I equal E divide I. However, you must be following. E must be in voltage, volt. I must be in ampere, and R must be in ohm. If we need, we have to change it. Okay, and this is the formula, just a formula. Voltage V equal I times R. I equal V divide R. Now we're talking about power. Okay, power formula, they get few different volt power. P equal V times I. That's the one formula. The next formula will be I square R. Okay, and the last one will be V square over R. So basically you get three formulas to calculate the power. Okay, the thing is when the current flow through the resistor will be hot. That means electrical converting to the heat. And if you want to know the power dissipation in the resistor, then you can use this kind of formula. Okay, I will be quickly go into this part. I want to try to see just 1 minute here. Okay, I can be stop that one here. Okay, I want you to do the quiz number 1. Okay, now Wednesday, get back. We start with the series circuitry. I planning take about 2 weeks maximum to get done. Okay, on up the DC. The third week will be going to electronic. Okay, so now what I want you to do the quiz here. If you already download your quiz number 1, and now you can do it. Let's get a multiple choice. You can pick A or B or C or D. I given you 3 minutes maximum for 2 questions here. Okay, quickly, I want to set up this thing quickly. Okay.
Hey.
If you already bring it.
Are you saying we should do these quizzes now?
Yeah. Let's see, can they run it?
A. Is A.
After you do it, on Wednesday, I go through it, try to give you the right answer.
T.
And this lecture today will be put on the YouTube tomorrow.
Yeah, so the quiz, the quiz is on the website. So you can go into the quiz, go to the handout, and then scroll down to the second one on the list. And then you click on, you can download that. This quiz is for you to practice for yourself. Okay, so go ahead and take it, and then just kind of keep track of it, the answer on your own sheet of paper, and then we'll be able to go over it when Mr. Pham go to the next lecture. Okay.
Hi, Mr. Sam. So
Yes.
how can I down the electronics?
Okay, so
the website you say?
yeah, it's on the website. I think yeah, because you said you can't open up the last one, so I don't think if you can open up this one too. So there is something that is going on with your setting on your Chrome. So in order to do that, I think you probably have to do is go ahead and delete your Chrome and then re-download your Chrome and
Re-download.
yeah, you have to re-download. Your first thing you want to.
If you get a problem, you can text to me. I can on Zoom to help you out. Okay, now that one we already put it on your on the website. You can download it. Try to do it. Okay.
Right.
The thing is now we almost time out. I don't want. So I just try to make sure. Whatever we learning, that's what we're doing here.
Letter A, can you mute
Mr. Pham, mute the mics, mute the mics.
Right.
Professor, you can mute everyone,
Yeah.
Professor, you can mute everyone. So I'm assuming on these quizzes, we should not use a calculator?
You can.
Will we need to purchase a scientific calculator for this class?
No, you want to do is go through and just do as best as you can. But like you said, once you work once you start working, because we're going to use a lot of Excel, you can do most of these things, do the calculation on the Excel spreadsheet.
Okay.
Okay. So that's why I said it's not necessary you buy the calculator. You can use your calculator on your computer. You know, you can put that one on and then do your calculation. You don't need to buy a special calculator. But if you have one, go ahead and use it.
So Sam.
Yes.
Yeah.
I'm here. So where do we find the answers to verify our
Mr. Pham will go over it, like he said, on the next lecture. So
Right.
go ahead and try to do this as best as you can and keep track of all your answers. So that way when he goes over it and you.
Okay, thank you.
The thing is, I supposed to get it done for today, but just the first day, so I don't want take too long. Okay. Normally done the quiz for 30 minutes, 3 minutes for each question. Okay. And after that, I can go over to even do the right answer explanation for you. How come I get that? Okay. So everything will be recorded. So if you're missing, you can go to the YouTube and you can watch again. Anything else, anything you not quite understand or you get some question, anything, go ahead before we can stop it.
So the student was asking about the class schedule. So the class schedule, we are here, we are working on Zoom Monday to Thursday, and we have class from 5 p.m. until 7:30 p.m. Okay. And then, like I said, I do have my office schedule hours, so which is like from 1 until 9 p.m. So if you need any help, you can text me on those hours. And then if those are not fitting with your schedule, you can always text me at different time schedule, and I will try to find out if I have a time available to work with you if you prefer earlier morning. Okay.
Right before bedtime?
Yeah, if it before bedtime, you know, you can text me. If I can't, then I'm going to tell you I can't because I'm going to bed. All right. Where do we send the quiz? Okay, this quiz, yeah, you just do it on your, and then just kind of save it on your computer or save it on your, just on your sheet of paper for now. And we're going to go over it.
We don't have to upload.
Yeah, okay, yeah, this one, some of you have not done scientific notation before, but you know, just go back into the handout and read the handout, and we want to see if you, and then just do some practice, and then you're gonna get more practice as you go through the semester, okay? And you will get better and better at doing this and converting from like scientific notation into
So we do it and we upload it?
No, no upload.
Okay.
Just save it on your computer. Just for this one is like a practice quiz. Just for you. Just make sure that you know, and then we will be going over it together.
Okay. Thank you.
You're welcome.
Oh,
Sam, day. Okay.
Yeah. So this is from 1+7T. Yeah, where have you been? Yes, we are doing a quiz. It's in the website. You can download you can go to the website, click on handout, and then you want to scroll down to say fall 2021, and then there's a handout there. And first thing, it was the DC fundamental handout, and then you got the quiz 1. So you go click on quiz 1, and you can go through that. There's a.
You can share for them to make sure everyone Nowhere.
Sorry, I was working on a job. Maybe I missed the part of the lab. Do we need to go to school for lab?
You mean on the Zoom, right? Or on the real lab?
Simulation is a piece by Mr. Fan.
Yeah, simulation mean on Tuesday and Thursday. You missing, you can go to the YouTube. He have to record it and put on the YouTube.
So the simulation.
Right.
We're doing.
Both, you know, lecture and also lab. They both be put on the Zoom into the YouTube next day, so you can read it.
Okay. Gotcha. Thank you.
Yeah, the thing is we want to save your time or help as much as we can.
Okay, let me go ahead and share the screen. So I'm going to share a screen. Okay, so let me minimize